we're told the derivative of a function equals x to the negative third. That means there was some original function. We don't know what it is. Oops. Original function, so that we took its derivative and it came to be x to the negative third. So you've got to think about negative exponents and what happens with them. Like if you had x to the negative seventh, we'll say, so just something completely different. Then the derivative with respect to x is going to be negative 7x to the negative eighth, right? Because we go one step back. Like negative 7 subtracted by 1 makes negative 8. So the power rule means when we take a derivative, we subtract 1 from the power. If you want to go to the opposite direction, if you want to take the antiderivative, we say, you should be adding a power for x. But look, this isn't going to happen if we take the derivative right now, right? If this is our f of x, then the derivative would be negative 2x to the negative third. It's close. We got the x to the negative third part, but there's this pesky negative 2 out front. So we got to balance. We got to take out that negative 2 by multiplying by negative 1/2 out front. Now, if you take this derivative, it turns out to be x to the negative third. You can verify that yourself. However, isn't this also going to have the same derivative? If you take a derivative of this function, go ahead and pause the video and take the derivative. It should also equal x to the negative third. Or this will. Or this will. There's an infinite amount of different constants we could add or subtract to the side. So we do a plus c off to the side. That's the arbitrary constant c. We don't know what that number is. It's an infinite amount of options. And that's why it gave us this initial value information. It's saying if you plug 1 in for x, you should get out 4. In other words, if I plug in 1 in here for x, I should get out 4 over here for our y value, our response variable. So 1 in for x, and then you can use a calculator if you're easy with your negative exponents, but that's going to be 1. So if I add 1/2 to both sides, I'm going to get 4 and 1/2 is c, or that's 9/2. That's probably better. So put that all together, and the final answer for this question, we need a function so that its derivative is x to the negative third, but it also has this to be true. And that's where we got that 9/2. We just found out we're adding 9/2 here, so that's the answer.